Hello guys, welcome back to my channel, and for today's video we'll be solving hypothesis testing related problems. First off, what is hypothesis testing? Well, hypothesis testing is a statistical interpretation that examines a sample to determine whether the results stands true for the population, meaning that the hypothesized sample will be tested if it's true or false. To further understand this concept, let's solve an example problem. So the problem is that a pearl farm produces pearls ranging at 17 millimeters in size on average. An employee believes, however, that the pearls on average are not 17 millimeters. Using 50 pearl samples, he measures that the average size of pearls in the farm are 14 millimeters, with a standard deviation of 2.7. A. State the null and alternative hypothesis. B. At a 95% confidence level, is there sufficient evidence that the pearl farm does not produce 17 millimeter pearls on average? So how do we solve this kind of problem? Well, according to the question, we need to state the null and alternative hypothesis. So that's what we are going to do first. Upon analyzing the givens on the question, our null hypothesis is mu equals 17, while our alternative hypothesis is mu but not equal to 17. And since our alternative hypothesis is not equal to 17, meaning that it could be less or more than 17, the test that we will use is two-tailed. An example of a two-tailed test is this picture on the right, which is the bell curve graph. The rejected regions represent the tails, hence the name two-tailed test as there are two of them. Additionally, since our sample size, or n, is 50, we'll be using the z-test because it's large enough and more than 30. Otherwise, we'll be using the t-test, but that's for another story. In using the z-test, we'll be needing our confidence interval in order to find our z-score, which is our second step. And our confidence interval is 95%, according to the question. Translate that into decimal form, we'll get 0.95. The formula for getting the z-score using the confidence interval is 1 plus the confidence interval, or CI for short, then divided by 2. Let's insert our CI on the formula, and we'll be getting 1 plus 0.95 over 2. 1 plus 0.95 is equal to 1.95. Then divide that by 2 and we'll get the z-score of 0.9750. Locate that at our z-table on our right, and we'll get 0.9750. Now that we found our z-score, let's look for the critical values, which can be obtained by adding the numbers used in locating the z-score, which is right here 1.9 and 0.06, and adding them, hence our critical value of positive and negative 1.96. Why positive and negative? Because we're using a two-tailed test, which has two rejected regions, one at the left as the negative and one to the right, which is positive. A visual representation of that is this bell curve graph. In this graph, the confidence interval is 0.95, which covers almost all of the graph, leaving out our two rejected regions on both sides surrounding it. You may notice the regions are both 0.025, because when you add 0.025 to 0.95, we'll get 0.9750, which is our z-score. Below the graph is our mean alongside with our critical values, positive and negative 1.96. Now that we've visually represented what our resulting curve will be, let's now get into solving the problem using the given. So our given is 14 as our sample mean, 1.9 as our standard deviation, 50 as our sample size, 95% or 0.95 as our confidence interval. Afterwards, let's apply the given to our hypothesis testing formula, which is z equals x bar minus mu over the standard deviation over the square root of n. And our formula would be 14 minus 17 over 1.9 over the square root of 50. 14 minus 17 is equal to negative 3, and 1.9 divided by square root of 50 is equal to 0.268. Divide negative 3 with 0.268 and we'll get our z computed value of negative 11.19. If we're going to put the z computed value in the bell curve graph, it's going to be placed in the far left in the shaded area or rejected region, which is shown in this bell curve graph right here. This implies that we should reject the null hypothesis since our computed value is outside the range of the confidence interval. And so, for our conclusion, with 95% confidence, we can conclude that the aforementioned hypothesis that the pearls being produced by the farm are 17 millimeters on average is false. And that's all for today's video. I hope it was well understood. Thank you for watching, and I'll see you next time. Bye bye.